Welcome back from coffee, and welcome to the second part of the morning, where we will be addressing two important sessions. The first one will be moderated by Stephen Ramage, CEO of the Committee of Earth Observation Satellite, CEOS, and is about space-based data, data cubes. We have a distinguished a set of speakers from all regions, and Stephen will bring us through this journey of challenges and actions needed for space-based data. Thank you very much.
Thank you. Morning, everybody. So for those who don't know, CEOS, the Committee on Earth Observation Satellites, is about 65 agencies, mainly made up of space agencies. And they were, CEOS is 40 years old this year. So CEOS was a contributing PO, participating organization in the formation of GEO 20 years ago. So, and I think without CEOS, a lot of the data, you know, you heard Barb this morning, you heard Gilberto, a lot of that wouldn't be possible without the work of CEOS. So it's great to be here. CEOS is also across the GEO work program, contributing many different ways and also sits on the executive committee as an observer. So we're very involved with GEO, or I am anyway. So I'm not going to talk much more about CEOS, but we have a great panel here, and our first speaker is Xu Xiang, and he's going to give us a perspective from Asia Oceania. So over to you.
Thanks, Chair. Good morning, everyone. So I'm from the CAS. So this morning, I would like to review the recent progress and the joint effort about data sharing and service in AO Asia Oceania range under the framework of AOGEO. So, oh yes. So as you know, AOGEO has developed into a regional GEO with 22 member country, deep participation, and also we have 12 participation organizations. Asian Oceania range is a huge range with more than 16% of world population, but in balanced situation or status on Earth observing and application capability. So from very beginning of AOGEO, I mean at the initial stage, the data sharing and the service is are the key components in the structure for AOGEO. As you can see, we have dedicated task group like data sharing, data hub, and cubes. Meanwhile, the developing thematic data set and application service, also the emphasis work for each task group from 1 to 9, and also as a very special activity of AOGEO IPS, try to link the data source, information technology, and also application service for the end user. So we are trying to promote the application of kinds of data set in this region. Even we have AOGEO symposium and workshop along with training activity which held annually to conduct this kind of activity. What we are doing is try to improve the linkage and the connectivity between the different activity from contribution of various stakeholders, like on country level, a lot of countries do a lot of valuable work on the data sharing, like China GSDSnet, and also our Japan colleague developed DIAS, which provide kinds of information service for the regional user. And also Australia colleague, they are trying to promote the ODC. I think a lot of colleagues already talk about that. So what we are doing is try to promote the deployment of AO Data Hub, then build the bridge from data to the knowledge. So I think we just follow the concept of GEO to do this work. So you can see from this diagram, we are trying to balance the kinds of different data source, data service, and try to develop application support system, data management system, along with the data processing system to promote the case study and application in different fields. Take some example. This is a picture about the China GeoDSnet. due to the incomplete statistic from the 2016, more than 4 million Chinese EU data can be discovered and accessed in the GEOS portal. So I think I had a talk before I come here with my colleague Li Guoxin. He is the director of NODA, and I think China and other countries are trying to do more, contribute work on the national level data sharing service. For other channel, the stakeholders are trying to provide different support to enhance the Earth observing capability. For example, in aspect of technology, we develop a lot of tools like Spectral Earth, which is funded by the Ministry of Science and Technology, and also under the framework of BRICS STI, we also developed the processing technology for data calibration and validation. I also have a deep cooperation with regional society or association, which focus on the regional issue like Hindu Kush Himalaya, and also the country data service along the Belt and the Road. For Knowledge Hub, we try to develop structuralized knowledge following OGC standard, and with the support of this system and knowledge package, we create knowledge graph for more than 450 remote sensing satellite, and also ontology resource model also developed by our Tsinghua University colleagues. So without this supporting of this resource, we are trying to adoption of multi-source satellite data by introduction of the AO data hub. So you can see with this system, we can improve the flexibility and the functionality by utilizing different effort from different country or organization. For the service, we try to align our objective to the geostrategic priorities like SDG and the Sendai framework. So we try to provide the key elements data set for implementation of SDG. And also we have done a lot of work in the disaster monitoring and quick response. For example, the Turkey earthquake in 2023 and also flooding in Russia as well. For future work, we are considered to enhance the link between the data to information products and to knowledge. So as you can see, there is an increased demand for the semantic remote sensing products, but we also get strong support, more and more support from deep learning and cloud computing technology. But there is a obvious tendency on utilizing AI, just like the post-2025 strategy mentioned, the Earth intelligence needs strong support from artificial intelligence. So there are also some key points we need to focus in the future work. For data section, we need to improve intermediacy of the service. That means we need provide the user timely data. But most important, for information products, we highly need the high quality shared data. So that means we need to improve data processing capability on the multi-modality with large scale model, and also the networked calibration and validation definitely will improve the quality of our data set because it's from various sources. And also for semantic products, I think we need to develop data set which provide essential variables for the climate change research or earth science research. And digital fusion and visual computing is also very important technology we need to develop if we want to support the vision of the key goals of GEO program. So there also definitely is some difficulty when we're talking about the remote sensing keep increasing, and also the demands from user are different here, also complex. So we need to focus on the open data policy, which our colleague already mentioned, especially for our AO community, and also the processing level of satellite, as I mentioned, especially we do not have enough standard remote sensing products, and also research on the models and the method with support of big data is very important. And finally, the scenario-driven fusion. I mean, we talk about quite a lot about data integration, but how do it? I think scenario-driven is a good solution. Next step in response to the opportunity, I think adoption of open data queue and also ARD will also our important work in the future time, and also the integration of storage and the computing facility like cloud computing and deep learning is very important. As I mentioned, the network, the calibration and validation work is very important for the high quality data set. In the framework of the AOG, I think this is our very special feature. We need to strengthen regional cooperation, like extend the IPS to improve the connectivity between the different resources, between the different multi-scatter. Is very important capacity building as well, I think. Okay, thank you very much.
谢谢你. So, if you go to ceos.org/ARD, you will find product feature specifications. You will find ways to do self-assessments on ARD. There's a lot of stuff in there that really marries quite well with what's just been said. What's also good is that there's this whole cloud native geospatial activity that's coming on board with, you know, we've had OGC standards for a long time. And actually there's a brilliant description of cloud native geospatial on the OGC website. It's probably the best description I've found. And you know, we've heard here about STAC and COG, so Spatial Temporal Asset Catalog, the cloud optimized GeoTIFF, some of these other things that are coming on. So I think this is a theme that's going to come through all the presentations, but it's something maybe in the discussion it'd be good to dive a bit deeper into. The other thing that I found really interesting in your presentation is most people today, when they talk about artificial intelligence in the context of Earth observation, they're talking about machine learning and what we've done. And you talked about deep learning and Gen AI, and there's not so much discussion that we're seeing around those topics. So maybe that's something we can delve into later on. So thank you for that. Our next presenter is Jean Dezat, representing Europe. So over to you, Jean, if you'd like to come here.
Good morning, everybody. So as Steve said, my name is Jean Dussart. I work for the European Commission and the Department of Research and Innovation, DG Research and Innovation. And we have prepared this presentation together with my colleague of the Defense Industry and Space Directorate General that is in charge of the Copernicus program in the European Commission. In GEO, I'm the European co-chair representative supporting our GEO co-chair Jean Adrec, who is our Deputy Director General. I'm as well the principal representative in the program board for the European Union, and together with my colleagues of France, but as well colleagues from the Joint Research Center, we coordinate the EuroGeo initiative. So why to talk to you about the Copernicus Space Data Ecosystem? It was mentioned in the introductory video of Gilberto this morning, because it's aimed at contributing to building an attractive European ecosystem to access and process Copernicus Sentinel data. So that means it goes well beyond just a traditional data platform. It offers service as well to transform, to go along the value chain and start offering processing service, going from data to information and knowledge. So what are the components of this big Lego ecosystem? You see, first of all, which kind of data do you find in this environment? The full Sentinel data online repository, very important, of course, and is something that resonates quite well with what Bente said this morning, is full open access data. We have as well what we call the Copernicus contributing missions data. Those are the data that are needed to operate some of the Copernicus service and that cannot be provided by the Sentinel satellite because of sensor or spatial or temporal resolutions. For example, when you have an emergency, an earthquake, you need to have a very quick data to organize the response to the emergency, and you need very high, sometimes radar-based data with sub-meter resolutions. And a number of additional Earth observation data coming as well from other missions like the Landsat missions. What can you do with this ecosystem? Of course, you would expect to have at least data visualization, some custom analysis, and I will come back together later to the different tools that are available in the ecosystem. All this is, of course, based on the cloud computing, and I will show you how those data and what are the interface to the catalog service, the view service, the processing service that are available. It's a large environment, a large data space, for, of course, the largest Earth observation program, authoritative source for full and up-to-date archive, the Sentinel user data. We have now currently, I should have updated the slide because I got some last statistic. Now we have over 80 petabytes, and we expect to increase, but I'm sure that this target of 100 will be reached well before 2028. It's governed by a service level agreement ensuring continuity and trust. So that's important as well. Sustainability of the platform, some long-term visibility up to December 2028 with an optional extension for another 4 years. It's an open ecosystem. So they put a lot of emphasis on the API to access, to catalog functionalities, viewing, processing functionalities. So more in detail, which kind of data do you find? Essentially, the four operating Sentinel satellites, 1, 2, 3, and 5P, plus complementary data. I mentioned already those contributing mission, but we have as well Copernicus digital elevation models. Most of the data, again, are available on an open and free basis. For some data, there are restrictions depending on how you qualify. So there are license and access restrictions that might apply. Quickly on the architecture, of course, it's a distributed and redundant infrastructure, basically distributed between two sites, an open telecom cloud in Germany and the Cloudflare cloud in Poland, all federated with very state-of-the-art security operation, access from the internet, but as well from some scientific networks like Géant. What are the tools that are put at the disposal of the user community, the Copernicus browser, to search, access, and visualize? There are plugins, for example, to let you access the data in your own preferred JS option. And again, we give precedence to open source solution with this QGIS plugin. Very important standard recognized interface to access directly the Earth observation data files or data, the stack that Gilberto was mentioning as well. OpenAO API, streamline data access, possibility to have Jupyter Labs for hosted analysis and processing, on-demand processing capabilities, traceability service. You see. A range of, it takes time to explore all those interfaces, but what is important, that means that anybody can build an application, and we're talking about, Andy was mentioning the aim that we want to make sure that Earth observation intelligence can be accessed from easy to use application, not only from a complex infrastructure, but from a smartphone application. With Open API, you can access directly those data and process them on demand. An example of this, the user interface of this browser, and if you are not familiar with this image, this is a Sentinel-2 image capture end of July, 31st of July of you see in the center, the campus of the university, 20 meters resolution, and you have already you see the possibility to run very simple geoprocessing operations to derive indicators like NDVI, and of course then you can download and further process further more advanced processing on the cloud. Those data, of course, need to be very well documented, and you have well described and standard-based metadata, so that confirms that this image was indeed captured the 31st of July at 8:30 in the morning. I guess it's universal time. It goes well beyond just looking at the data and enhancing their appearance. You can host and develop with a very open AO interface processing chains to derive and run on the cloud. If your expectation cannot be met by the public cloud, you can purchase credits and have your processing run on a commercial cloud. That means as well that for a user, the transition from public access to everybody to more advanced needs is relatively easy. So that was, and I see that I have 1 minute left, so I will just a bit accelerate, and that's show this transition between the data space from Copernicus to the commercial offering, what more you can get from the commercial offering. This is supposed to be, as we are talking, ecosystem. It's a system that will evolve and it is open to third parties. And you can imagine to have some specific application put for free or for commercial use, like a sort of marketplace, and that's it's currently developing, for example, for the Common Agricultural Policy monitoring. Some statistics of the use we have so far, as of the 12th of September, we had about 212,000 registered users across the world. You see a good balance between the different continents. So that means it's not European focus. It's an open system, even if the usage of the service is predominantly European. For the statistics, it's the volume that are processed. I mentioned those 80 petabytes at the beginning of my presentation. And I think that's just a slide of what we are cooking in the coming months, the new data sets, the new interface that will be developed. And I guess that the slides will be shared after the conference. And in any case, those data and the roadmap is regularly updated and is available. You see the link below the presentation. And I think that this is my last slide with the Hangzhou image taken again, you see 31st of July. Thank you for your attention.
Merci, Jean. It's like enough information in these slides to run like a 2-day lecture. So I don't know if you did it on purpose, Jean, but API was in your presentation about 15 times. And I think that's quite important. I don't know because I'm not part of GIDT, but is there an API strategy as part of all this work that's going on in GEO? I'm saying that because I did work with the UN and they purposely created an API strategy, which we could have a look at if it doesn't already exist. The other thing that Jean said, which I think is very basic, but kind of fundamental, is the spatial, temporal, and spectral resolution, the importance of those three elements when it comes to the data. We need to keep repeating that so that people understand those basics. Also, the vast volumes, 743 petabytes downloaded, and how to access and how to process and analyze. And you talked about different methods of processing. So you talked about the on-demand processing, but also the hosted processing. So I think those models are quite important. And maybe one of the most important things I think I heard you say was enabling public and commercial third parties. So it's open across the whole ecosystem. So thank you for that. Our next speaker is in disguise. This is in fact not Charles Mwangi. This is in fact Felipe Carlos. So Felipe, today Felipe is going to be Charles. Good luck.
Yeah, so thank you so much, Stephen, and for all of the speakers. So Charles, unfortunately, will not be able to join us in this ODOC, so I'll be speaking on his behalf. And his presentation was about the Kenyan National Data Cube initiative they are developing. So in this presentation, he presented the main issues they found and also what are the strategies they are using to build the National Data Cube. So to build this Kenyan National Data Cube, they are using as their base technology the Open Data Cube. So this is an open source library which helps us to produce data cubes and manage these Earth observation data cubes. So manage the metadata associated with these, with the images in the data cube, also to produce analysis-ready data in forms of data cubes and so on. And of course, when we are dealing with data cubes, we are dealing with a huge amount of data, and we need to find solutions for that gaps and transform that gaps in opportunities. So for example, to build a data cube, of course, we need to take care of the computational resources we are using, the storage that we need to have in place, software. Sometimes the current software available sometimes don't help us to process the huge amount of data that is required to produce the data cube, to visualize that data, and so on. And of course, by using such a solution like the Open Data Cube, they are relying on a very good and mature tool that helps. And there is, of course, been part of many national data cubes like Swiss Data Cube, the Australian Data Cube. So all of them are already using the Open Data Cube, and they're in Kenyan are also using now this Open Data Cube as their solution. And of course, why a Kenyan national data cube? So when we have a data cube in place for a country, for example, we have this possibility to do temporal analysis of Earth observation data. So this kind of analysis help us to, for example, understand the dynamics of parts of the country, and this helps a lot in the, for example, agriculture analysis, in the water management, and so on. And of course, building a data cube, we have a lot of target users, for example, governments, research institutions, private sector, and so on. So basically, all the stakeholders who are dealing with Earth observation data are the target users and can benefit from a national data cube. And what they already have in place is this data hub. So in this data hub, they are centralizing the data cubes, and also they are using these as a knowledge hub. And this is because to sometimes produce or manage data cubes, we don't have resources, a lot of resources available in terms of training materials and things like that. So they're trying to centralize all the lessons learned, documentation they are producing in this data hub. And to let users access these data cubes in a very good way, they are using these, basically they have defined these two components. So they have the end users using, for example, a web interface in this web interface, they use Jupyter Notebooks to access an environment where they are able to use and access the Open Data Cube, and then they can load the data and manipulate the data and do the analysis they want. And to make all this possible and to manage multiple users using this Jupyter Hub as a solution, they have as their base a Kubernetes cluster. So basically this cluster is used by the Jupyter Hub to provide the computational environment so users can access and use the data cubes to produce their analysis. And here, Charles also provided the current status of what they already have and what they are doing now. So they already have the initial server set up, and in this server they already have the Open Data Cube set up and running, and they already ingested data from Sentinel-2 and also Landsat 8. And of course, users have the possibility to access this data using the data portal I mentioned. And now what they are doing is improve the use of the resources and the servers they have with improvements and configuration in this Kubernetes cluster they are running. Of course, they're trying to keep things secure as well. So this is why they are working in configuring these firewalls and things like that in their data cubes. And they're also working with custom scripts and things like that to first manage the data and also analyze the data. And as challenges, we have some points here, like the satellite imagery formats and metadata. And this is because sometimes when we are ingesting data to produce a data cube, we need to deal with the different formats of metadata, keep things organized and standardize things inside the data cube. So to have the possibility to process the data and then create the analysis ready data, the data cube, and so on. And the last point as a challenge Charles mentioned here is this insufficient outdated resources for data cube. So this is something Charles is really vocal on. So this thing I already mentioned, we don't have a lot of resources in how to build a data cube. Sometimes we have, of course, materials in how we can do temporal analysis, but for create the data cube itself to allow users to do this kind of analysis. We don't have a lot of materials. So this is what I have to present to you. Thank you so much.
Obrigado. I think it's always hard enough to do your own slides, never mind speaking on behalf of someone else. So that was a great job. I heard a lot about Open Data Cube requirements, components, and implementation. We also heard obviously about the Kenya Data Cube, but there was reference to Brazil Data Cube and the Swiss Data Cube. And there's a great presentation by Greg Giuliani on the business benefits of the Swiss Data Cube and why they got funded, which has been presented in the context of GEO over the years, if anybody wants to access that. There's also, in the Radiant Earth Foundation, there's a lot of work going on around, I guess, the cloud native geospatial stuff, but there's also some people who are working on what they're calling modern GIS, where they're looking at automation of a lot of this work. And I think automation is something that most of us, so 1990 was the last time I programmed anything. I am absolutely hopeless at programming. Did any of you program? Anyone working in R, Python, JavaScript? Very few, very few. Okay, so I think that's also important to think about, you know, what are the languages that are being used and those considerations as well for the community, because some of the numbers of downloads are enormous, but it would be interesting to see, you know, what languages those communities. I mean, Gilberto talked about CITS this morning. I think CITS is primarily an R, but he says if you do Python and JavaScript, you can easily learn it. But that, Gilberto would say that. So thank you, Felipe. Now we are going to pass over to Africa again, to Kofi. Yep. And we're going to hear about his work at the Ghana Space Agency.
Good morning and thank you very much. So I'll be presenting from the perspective of Ghana Geo and what we are also doing in terms of space data. I'll highlight some challenges that we are facing and also what we are doing in this direction. So there are already existing satellites with sensors in orbit, already harnessing data, and we are leveraging on these data sets through the various repositories provided globally by NASA, by Copernicus, and other data sources in addressing some of the challenges in our country. Again, we're also liaising with some bilateral cooperation in assessing high-resolution data sets. So we are cooperating with China, with the China CAXA program to assess some high-resolution data. Having harnessed these data sets, we also have to use tools, open source tools like QGIS, open source platforms like have been highlighted by previous speakers in assessing space-based data and using space-based data in addressing challenges that we have faced as a country. Again, as from the government perspective, we notice that we cannot continue to be users. We also need to contribute to the space industry, contribute to data, make sure we are also doing our best. And by that case, we need to lay a firm foundation. So Ghana has developed a space policy, trying to mainstream space activities in the country, make sure they are connected and they are well coordinated to address national challenges, and making sure we achieve sustainable development, build resilience, and bring about development. And in addition to that, we are happy for being part of GEO, being part of AfriGeo and the global community, and through that, we're able to assess space data sets as well in a way of assessing data, building capacity, assessing resources, methodologies elsewhere, and contextualizing them to the Ghanaian situation. Again, there are challenges in this regard by those who are providing the data sets. I was amazed with the kind of infrastructure our colleagues elsewhere are having. We still have to build this infrastructure. base to be able to receive, to be able to store, and to be able to analyze and visualize our data sets and be able to build actionable insights that will help inform decision making. Technology, knowledge is always evolving, and therefore we need to build a capacity of Ghanaians to get them with the skills for deep learning, assessing the data and transforming the data sets into useful information for evidence-based decision making. Another challenge is we've had some project-based activities in the country, but because they are project-based, they also have their timelines and deliverables. And therefore, at the end of the project, everything ends. But we want to live beyond this so that we move away from project-based activities by making sure we mainstream these activities through the various government machinery so that they will be continuous and they'll be sustainable as well. In addition to that, to be able to access data, we are collaborating with various institutions like the European Space Agency, NASA, I've mentioned of the CAXA, and we are assessing all these data sets and using existing data cubes and platforms in assessing near real-time data, in building capacity, and using these data sets to inform policy in the areas of climate change, climate resilience, agriculture, food security, disaster risk management, so that decision-making will not be based on perception, but will be evidence-based, based on data that will drive development. In addition to that, when it comes to the users, I've mentioned that access to near real-time data is important. There are some challenges you need real-time data to address them. You also need data processing capacity. You need storage. You need a computing platform to be able to process the data and transform the data into useful information. And for certain applications, you require high-resolution data sets that are quite expensive. So these are some of the challenges when it comes to utilizing space data. But we're also working on our own to build local capacity in this direction. We also want to strengthen our international collaboration. What we don't have through collaboration, we can leverage on this strength and be able to move on and develop the products that are needed to solve the national challenges and also expand on the use of open data platforms. So in the future, once we have high resolution data sets, once we have the infrastructure that is also localized in our context, in our situation, then we can also develop the potential research products in the various areas of agriculture, for urban planning, for climate resilience. And in that way, we will also be addressing issues and challenges that confront us as a nation. And therefore, Ghana Space Science Technology Institute is being developed to become not just a research hub, but also become an institution that will coordinate space activities in the country and foster the development of developing these platforms, data cubes, sharing platforms, in using space data to address challenges. And then we promote satellite-based startups and innovations in Ghana that will drive the space industry. So Ghana launches GhanaSat-1 some time ago, and we are working to launch other satellites into orbit that will meet our context and also our situation. So there are specific data needs of the country, and we need to, having leverage on existing data sets, we also need to create our own, develop our own, and also share with the global community as well. So we are working towards developing and launching satellites also from Ghana so that we can harness specific data set that meets our specific situation for national development and also for national security. We are also working with Esri to develop the Ghana Geo portal, specific and to the context of the Ghanaian situation, develop tailor-made solutions to the Ghanaian situation. We want Ghanaians, those members of the Ghana Geo or the entire community to be able to access space-based data sets, be able to analyze the data set, be able to visualize them, create applications on that platform, and be able to use them to address challenges and issues facing our country and also facing the global community. Again, I mentioned about our collaboration with China. We are receiving about 2-meter resolution, between 2 to 7-meter resolution satellite data. Currently, we have about 80% coverage for Ghana. We hope to continue and sustain this relationship of harnessing and accessing these high resolution data sets to develop actionable insights that help us meet the various sustainable development goals and also driving development. So we are using space data in addressing the SDG goals. We're looking at protecting our forest resources, monitoring our forest resources, land use, land cover change, developing products and knowledge and data sets for evidence-based decision in agriculture, making sure our environment is monitored, our water resources are monitored, and we are able to use them sustainably for national growth and development. So these are some of the things we are doing, the challenges, the benefits, the future that lies ahead of us, and some of the products we are developing as a country, developing them and using them on our Ghana Geospatial platform and making it accessible to Ghanaians, members of the Ghana Geo, and also the global community. Thank you.
Medasi, Kofi. So I think that's kind of the essence of GEO, what you just saw, in terms of accessing data coming from different continents. So the data from China, data from Europe, data from USA, and how that's actually working to support what they're doing. I'm really interested in what was talked about there around the technical capacity in interpreting and using satellite data. I think that goes back to what you were saying, Andy, earlier on about all of this is pretty difficult to do, and you need quite a lot of knowledge, and you know, Kofi's pointed out it's not easy to find that. So where's the transition from this to your decision makers or even your policy makers? That's something that I think we need to explore a bit further. And also again, he stressed the importance of timeliness of data. So this real-time data that was brought up. It was interesting that you talked about national to global, but you didn't talk about regional. So hopefully that will become clearer, because I know you do contribute to Digital Earth Africa. So hopefully that will become clearer with our next speaker, who is Joseph Tuishimiri. Joseph, over to you, Monsieur.
Thank you, moderator, and good morning, everyone. I'm Joseph Tuishimiri. I'll be talking about Digital Earth Africa. And you keep in mind that when Jean Dussart was presenting about data, data consumers or users, Africa had a very tiny pollution. Maybe this should also be a good way to raise awareness. So when I was going through the GEO website, I found a lot of data providers, but at different levels. Some were satellite operators, like ESA, USGS, and many others. Others were intermediate, either providing technical support or even in terms of infrastructure, I mean, software and hardware, and others were at another level, like deriving information or transforming those data into products. I think that's where the Africa is. And for all this to try to inform different decisions across the continent, from environment, food security, urbanization, and many others. And we should make sure that we are impacting the health of the communities, especially someone who says small scale farmer, but also someone who will be impacted maybe by flood or by impacts of climate change. But also the international community should build their actions on evidence, and those should be mostly derived from the combination of EO dataset and also the in-situ dataset. But also NGOs are there as well to the dataset. The academia is where to develop workflows and methodologies, and also private sector to turn this into business models or to invest more money. And of course, you can't forget governments as Ghana and Kenya are doing. So for the Africa, the idea, our raison d'etre was to come and try to bridge the gap between data providers and users. We started with a freely available data set, Landsat from USGS, with a high time series from 1980s to nowadays, and Sentinel with a better spatial resolution, but with a limited time series. And those datasets were processed and hosted on the cloud space for people to access them free of charge without any restriction, even for commercial purposes. We started mostly by informing agriculture and food security, urbanization, land degradation, coastal erosion, and many others. So our data are at continental levels, but we can discuss with the user to customize the data set at small scale, depending upon the use case. So, of course, we know that without partnership and cooperation, this couldn't be possible. That's why, although we are inspired by Geoscience Australia via Digital Earth Australia, and of course the government of Australia provides some funding, the same as well as Australia Charitable Fund, and but we collaborate with the various institutions across the continent, as you can see, as implementing partners are from Tunisia and the other part. We have the OSS, AfroGist in Nigeria, Agreement in Niger, CSE in Senegal, RCMAD in Kenya, Science in South Africa, and many others to make sure that all products and services we are deriving from those data sets that are free available thanks to efforts by different partners across the globe could be well processed and also validated using data sets from ongoing initiatives. That's why we thank everyone that has been contributing. So I want to go back through what you call open data keep technology, because people have been mentioning it. But the idea that we think by providing those analysis data sets are free of charge, related capacity building, open Jupyter libraries, and also other ways of accessing those data sets, like very simple Teria maps, we could bridge the gap between data providers and users, and we can support governments, NGO, even the private sector, in solving several challenges, including climate change, even the reporting of the indicators, but also providing a cloud computing space could help us to bridge the gap of limited spatial data infrastructure on the continent, and of course, the efficient use of resources. Imagine if we have a mosaic covering the whole continent, anyone could access it from his or her own area of interest, and then we are trying to capitalize that resources. So some few of the services, even data or product, the cloud-free mosaics derived from Sentinel images covering the whole continent, being a monthly, 3-monthly, or 6 months or annual. Also derived from Landsat the same way. With the water observation from space, a continental product to understand long-term water trends, and the crop mask with the wetland research tool to inform the trend in new wetland, the water bodies service to inform management of water bodies, the coastline service, and many others that were co-developed and validated thanks to the technical support from various geo partners who are present here, even especially our implementing partners across the whole continent. The platforms, as I said, they are user-friendly to diversify, to make life easier for all our users. Like the Digital Africa map, we can do some exploratory analysis. You can do some small change detection and export or share the results. This is what big bosses need. We don't have time to go through heavy analysis. But the sandbox based on Python coding, inside it, we have a lot of developed notebooks based on Jupyter libraries, and that will help you to process data set, to run some analysis, to export statistics, maps, and even download raw data. You have to use any kind of software you want. Of course, you can use the classical softwares and also have online courses. You can log in and try to learn about those courses. And we think from data exploration, machine learning, interoperability, and we become more inclusive. So those are some of the use cases by our partners and users. The bottom left, water monitoring the lake, monitoring the flooding like around Lake Boringo, informing the management of giraffes, the mangrove vegetation in Zanzibar, informing the decision related, monitoring the crop trend, monitoring urbanization, monitoring the coastline, monitoring the rangeland health, and so on. So as I said, the capacity development program, it's up to people to learn, to log in and learn. A lot of users, above 2,000 have already completed the courses, and the same as well, our users are increasing across the whole continent. Of course, you can discuss whenever, especially on every Wednesdays, to talk about existing products and services. On this, I thank you.
Merci, Joseph. So he talked about data acquisition versus use. And I know in the sandbox, there are thousands of users. But then you go to what Jean was talking about, which is hundreds of thousands of users. And I wonder how are those different user communities connected into Geo? You know, is it just through Digital Earth Africa, or is it through some other more centralized function? Just an open question. I think, I mean, so that's a regional program for the continent. There's also Digital Earth Pacific and Digital Earth Americas. And I think there's a lot, I mean, at the end of the session on Digital Earth earlier this week, there's talk about having a convener activity linked to that. So again, how would that convener activity feed into some of the activities in GIDT and some of the more technical elements? What was interesting is a lot of people are still talking about the SDGs and working on the SDGs. And I can see that the work that you're doing on the SDGs would also have applicability for some of the other emerging themes in Geo, particularly around things like the Ocean Decade, around the Global Biodiversity Framework. So it'd be interesting to see if you explicitly talk about those, you know, we originally put the engagement priorities together back in 2015-16. How has that moved forward now? How does that connect, you know, with the work that you're doing? Because I think that there's a lot of relevance there. And then probably one of the most important things I saw in your presentation, which goes back again to the point Andy made, was it says different interfaces for different needs. And I think it'd be worth exploring that a bit further. So, no hablo español, entiendo un poquito, pero no hablo más. So, Mario is going to come next, and Diana, fantastic. So we have a translator. Good. I could have made it up. I could have just said anything for those who don't speak Spanish. I could have told you he was talking about, you know, saving the boy. He's going to talk about saving the world. But Mario, please, ven aquí. And this is Diana Mastracci from the Geo-Indigenous Alliance, who's going to help translate.
Bueno, primeramente quisiera agradecer a los organizadores por haberme invitado a este tan maravilloso país.
Good morning. I would like to thank the organizer for inviting me in this marvelous country.
Y mi cordial saludo desde la Amazonía a todo este público y también a los colegas que están siendo parte de este panel.
And my warmest welcome to my colleagues and my panelists.
Mi nombre es Mario Vargas, soy del pueblo Shuar de Sudamérica, Ecuador. En esta ocasión voy a tratar sobre un proyecto que estamos haciendo en una comunidad.
My name is Mario Vargas from the Shuar Nation in the Ecuadorian Amazon, and I'm going to talk to you about a project that we're currently doing in our community.
Quiere decir que los datos de la tierra utilizados en el proyecto de monitoreo de vida silvestre denominado Proyecto CATIP. CATIP es un animal, mouse o rata en el Ecuador.
I'm going to talk about how we're using Earth observation data in the project called CATIP. CATIP in the Shuar language means rat.
Quiero aquí exponer sobre la importancia del uso de los drones que hemos venido en los últimos tiempos utilizando en la Amazonía.
I would like to talk to you about the use of drones that we have started using recently in the Amazon.
Para los pueblos indígenas ha sido un reto bastante fuerte y también ya que en la Amazonía no tenemos tecnología y lo que primero hemos hecho es capacitar a los jóvenes denominados monitores.
We are currently facing a very challenging time in the Ecuadorian Amazon, and because of the lack of technology, the first step was to ensure that the youth was able to use the technology. We call these youth the monitores, the rangers.
Para nosotros es tan importante preparar a la juventud y también de esta forma, bajo los conocimientos de los pueblos indígenas, podamos aportar a la academia y también a la comunidad científica.
For us, it's very important to train the youth in order to be able to provide data as well to the scientific and academic institutions.
Un poco puedo mostrar el área del proyecto que estamos llevando a cabo en la Amazonía para monitorear lo que es el tema de las ratas. Esto con uso de drone. Es un proyecto primera vez utilizando estas herramientas y también los mapas.
So here you can see the map of where we placed the sensors in this project. This is the first time that such a project is being carried out in the Ecuadorian Amazon.
Para nosotros es un proyecto bastante novedoso porque las ratas aparecieron justamente cuando hubo la época de pandemia y estos amigos, diría, estaban atacando a todo lo que se consiste a alimentos de las familias Shuar.
This is a very important project for us because the rats appeared during the pandemic and they are eating all our food that we're planting.
Entonces, bajo esta preparación a los jóvenes hemos podido hacer los primeros mapas pasando bajo varios procesos de capacitación. Son jóvenes que no han ido a la universidad, pero están intentando de usar mapas, de usar drones para interpretar y también obtener resultados de qué es lo que está pasando con nuestro medio ambiente.
So we've done a lot of training with the youth. These are youth who have never gone to university, but they're very enthusiastic about using new technology. And now, thanks to the drones, they are understanding this new connection with the rats.
Entonces podemos entender también que quizás esto es parte del cambio climático que estamos viviendo todo el mundo. Entonces sé que a futuro vamos a tener resultados positivos o negativos de este proyecto.
So we might think that this could be a cause of climate change, and in the near future, we'll be able to have either negative or positive outcomes from this project.
Como pueden ver, ahí tenemos a los jóvenes preparándose en temas de manejo primero de GPS, manejo de mapas, también manejo de drones. Son jóvenes que no conocen todavía la universidad.
So here you can see pictures of the youth in training. They started training using GPS, making maps and drones. And as I mentioned earlier, these are all youth who have never gone to university.
También ha sido importante el conocimiento nuestro porque hemos con estos jóvenes también tenido la oportunidad de reunir con los sabios para entender de cómo utilizar los espacios y tener informaciones importantes de los animales.
Our indigenous knowledge is also extremely important, and thanks to this project, we have been able to meet up with the elders.
Entonces, estos jóvenes en este momento, como podemos ver, están poniendo las cámaras trampas, los sensores, y ellos pasan por un tiempo de una semana y ellos pueden bajar los datos para poder almacenar. Todavía no estamos interpretando porque tenemos un tiempo de entregar la información.
So here you can see them placing the different types of sensors. Here they're placing a camera trap, and they usually go and collect the data after a week. And currently we're in the process of collecting data.
Estos jóvenes tuvieron un entrenamiento de una semana, gracias a Diana también y a un profesor de Estados Unidos, de la cual nosotros desde este espacio enviamos un saludo.
These youth have had a training in which I took part together with a professor from the University of RIT, and he's taking this opportunity to say hello to Professor Vodacek.
Eso es la familia Shuar, que estamos con un proyecto bastante novedoso. Como podemos ver, ahí está la familia. Son jóvenes que a nombre de ellos estoy aquí presente para dejar un mensaje de que tenemos que trabajar mucho por el tema de cambio climático y también necesitamos más apoyo en el tema de utilizar esos datos de la tierra.
So I would like to share a message from the youth, from all the rangers that you can see there, that we still have a long way to go to tackle climate change. And I would also want to ask further support from the community.
Esos son los materiales o equipos que estamos utilizando. Para nosotros son súper nuevos. Sí.
So these are the new tech that we're using. This is all very, very new for us.
Y lo mismo quisiera dejar un mensaje que alguna vez en el futuro podamos hacer este tipo de eventos en la Amazonía ecuatoriana o en Sudamérica.
And I would also like to leave a message that hopefully one day we will be able to make this type of events in the Ecuadorian Amazon.
Gracias por su amable atención.
Thank you so much for your lovely presence.
Muchas gracias to both of you. So that last session was really interesting in terms of like youth engagement through the Rangers and also local community engagement. And also this is a space-based data session, but obviously in situ just came through very, very strongly and showed how important that is as well. What would be interesting, and I don't think we've got time to answer it now, but how can the data cubes serve the Indigenous community? What could we do? Is there stuff already happening through different activities through Digital Earth Americas, or activities in Digital Earth Africa that could be copied, or even the work in Digital Earth Pacific? I think that would be something to look into a bit further. When Paula asked me to moderate this, she told me that what we were doing was we're building a cookbook, and what we're looking for are recipes to go into the cookbook. And those recipes are essentially services like the Crop Watch Monitor and other things. So my question to the panel is, what do you think are important elements of the cookbook? And I hope my analogy makes sense and you understand it. I mean, I can ask you more specific questions if that's clear as mud, but if that makes sense, I'd love to hear from you. Joseph, you're smiling, so I'm going to go for you.
Actually, I didn't get your question. That's why I was smiling. I didn't get the question very well.
So we're trying to determine what are the components for the geo infrastructure. So in terms of services, what are the things that are important? So, like we've talked about a lot, from APIs to capacity development to infrastructure to tools. What do you think are those important elements based on your experience with Digital Earth Africa? We've got to focus on, we can't do everything. So what do you see, you've talked about challenges and opportunities. What do you see as the real things to sort of drive on, to hone in?
Oh, thank you. I got your question. Actually, when I think about those data cubes, the first thing is a partnership, because with partnership you understand what the community needs, what is needed at high level, what is there, and what new you are bringing, and also you're able to discuss with the data providers, and also to know expert to contact, and so on. So that is the first thing. The second also is data accessibility, and because if we have data, your data, yesterday someone mentioned also in situ data, and because everything you provide should be validated using in situ data. So that's the second thing, and also the third thing should be capacity building. So in terms of the uptake, the analysis of the data sets, because most of the times we have data, but people are not aware, or they can even be able to analyze at all stages. So the question, seeing that EAC is providing data sets, but the uptake in Africa seems a little bit low. And also the other thing, this capacity building should be maybe high level capacity building. Experts should have a knowledge, and people working in NGOs, government should have a knowledge, but also starting the universities, young people. I like the youth knowledge hub here. That's a good initiative, because I think we are getting old. You need some young guys to step in to keep our work. So for me, I think those are the most important. Of course, some awareness raising, also starting by high level. Some government endorsing this kind of initiative like GEO, and I think also gives strength. So 5 elements according to me, but none of them is greater than another. They should go together. Thank you.
Thank you. And at any time, if you feel you want to speak, ask a question, just raise your hand. And if I don't see you, just shout Ramage. Yeah, and I will come to you. Does anybody else have an immediate view on that? Jean? And Jean, I'm really interested, like, how do we connect those hundreds of thousands of users somehow through Geo and, you know, the work that's been done on the Geo infrastructure?
Well, maybe the connection to Geo.
It's a long
In
way.
principle, it's straightforward because, okay, we're coming back to those APIs, I think it's a crucial concept, and especially when you develop an ecosystem made of multiple components, that they can be reused outside of that ecosystem. And so for the Geos portal or the Geos knowledge hub, there's no barrier, technical barriers to access the resource available in the ecosystem. To come back to your cookbook analogy, I think that to make a good recipe, you need good ingredients. So it's important that whatever the system you develop, yes, you have the data, you have the interface, you need to have good tools to process the data. You need a robot maybe to mix your preparation, your cook. Maybe something that is still not yet present in many of the system, a rating system at the end. Was the recipe, was the plate, was it good? Like TripAdvisor style, how many items up for your recipe, so that could maybe increase the interest for some service, increase the user base for those services if they are well rated.
I think it would also be interesting to see out of your hundreds of thousands of users, how many are the same that are the FAO users, you know, the 150,000 that were presented there. I wonder how much overlap, how many people are going to different systems for very similar things. That's something that you know, how much time do people have? How many platforms do they need to go to? Is there a better way to organize collective intelligence?
Maybe that's where I think Geo could make the difference, is to helping to drive the user, the members of the user of the Geo community, the Geo work program activities, or a sort of super wizard. Tell me who you are and what are your needs, and then Geo can advise you on where to look to find your space data, to find your in situ data, to find your algorithm on the knowledge hub. Something that is still missing is in this very complex and sometimes fragmented landscape.
And you, do you have something to add on that?
Yes, I think just a supplementary remark. I think as the colleague mentioned, data hub, I think is just like a clustering of data source, software, and analytic tools. So I think the user, especially local user at national or regional level, can develop their own system upon the demand. I think I just follow the John said. The key points is I still want to emphasize how to assure the quality if we want to promote wide data sharing. So if we try to define recordable and accessible, maybe for next step, we need to do more work on our action on the traceable. Yes, because we have more and more image data, more and more data set from different scientists or source. A lot of work repeated by different team group. So I think except the strong support with Digital Earth or ODC or other technical system, policy or awareness on how to develop widely shared data set is more important. That means if we're talking about knowledge hub, this is a need a standard. I mean, it's difficult, but we need to develop some specification for widely used or acceptable data set aligned to the strategic objective defined by the GEO.
So, I just want to remind people in Zhu's presentation, there was something called QA for EO, which some of you might not know about, but that was done with GEO and CEOS many years ago. And it's a fundamental basis around the quality elements of Earth observation. There's also a working group on calibration and validation in CEOS, which a lot of people are contributing to as well. So thank you. I think that's Amos, is it?
Yes, Amos.
On you go.
Okay. Hey, I'm very loud, am I? It's good. All right. Okay. So thank you, panelists, and for your presentations. In fact, after listening to all of them, it proved one message, that the Geo Knowledge Hub should be seen as the vehicle for everybody who is interested to cook, to come to the Knowledge Hub, and whether you want a pizza, whether you want tuosafi from Ghana or fufu, you can be able to get the right way on how to do it. I cannot emphasize how much this is important, but I think from Digital Earth should be looking into ensuring that they are connecting to the Geo Knowledge Hub, because that is important. If it is Esri, they should be looking into how their information can be visible through the Geo Knowledge Hub. If it is LDN flagship, GeoGLAN, we should all be seeing how we link up to this service. I see a lot of opportunity in this. If you take the Great Green Wall Initiative in Africa, we are talking about more than 1 million youth that are using, they are looking forward to Geo to see how they can develop applications and start businesses of their own. So if we can work hard to ensure that the information within the Geo Knowledge Hub, not only with what I call step-by-step approach, but with some short videos to tell us if I am interested in crop monitoring, how do I go about it with short videos? I think that will really make a lot of case for us. Then to the last point, because I want to, from Ghana, I want to add some other aspect that we are working on, but which was not captured because of time. Infrastructure is going to be critical. And already in Ghana, we are already realizing that to build all these ground stations, to receive satellite data, and with all the different satellites that are in space, the message which was mentioned during some few days ago about the fact that we need to deploy AI in space is becoming very important. So in Ghana now, we are collaborating with a local company in China in trying to see how we can, based on some of the technology that is out there, to see how to use AI algorithms in space to specifically look at issues, whether it's mining or it's about crop monitoring. I think this is also something very important going forward as we go through all these discussions. Thank you, Stephen. Thank you, panel.
So can I just qualify on your last point? Do you mean to transmit data that is cloud-free using AI to determine that?
Data, we don't want to talk about free anymore. in the context of Ghana. Because you see, when we talk to our ministers and we say it's free, they forget that we will need a certain server, we will need a certain technician to sit there, to watch, to analyze. We need somebody to be trained. So we say we are coming with a package, but these are the benefits and you need to pay for that. So I think within this community, we must also be realizing there's a need to emphasize that it is not just free as in free. And my friend from Digital F said, yes, the platform of Digital F, yes, will give you the tools, but you need somebody to be there, somebody to be paid to do all this analysis in the various institutions. And this is not free. They need to be ready to pay for it, to get the service and to maintain it. Thank you.
Okay, Medasi. So maybe to Mario, what do you see as from your experience, the best way to engage with these local communities and with youth? What would your kind of advice be back to Gio?
Lo que podemos mirar es que la comunicación es muy importante para la juventud y también para yo. Tenemos que mejorar porque solo estamos pensando en el otro continente. Estoy mirando la realidad de Sudamérica, entonces al menos yo vengo de un país que es parte de la cuenca amazónica, que está en 9 países y estamos en 9 países los pueblos indígenas. Entonces, fundamental para nosotros, para los pueblos, es mejorar la comunicación. Y si mejoramos la comunicación, podemos hacer grandes cambios para la sociedad y para el planeta.
So I come from a country that belongs to COICA. COICA is an indigenous umbrella organization in the Amazon, which comprises 9 different countries. And I'm speaking about the reality in South America, and I believe that communication plays a key role, and that if we enhance our communication, we will be able to make a lot of positive changes for society.
Otro de los pilares fundamental también es que en las comunidades nuestras no contamos la forma de comunicar, por ejemplo, en este caso, el tema de Internet. Y si nosotros tenemos este servicio, puede ser fundamental abrir cadenas o espacios de capacitación de forma online.
Another major pillar I would like to talk about is the lack of internet that our communities face. And if we would be able to have internet, this would enable the communities to access online learning platforms.
Esto sería muy importante que dejo como mensaje porque para los jóvenes trasladarse a la ciudad es súper carísimo, los vuelos, las navegaciones. Entonces, creo que hay que aprovechar el tema de la era digital para preparar a los jóvenes, pero desde sus comunidades para que no pierdan su identidad, la cultura, y puedan seguir siendo los protectores de la naturaleza.
Gracias.
Sorry, and because it's very expensive for the youth to travel to other cities to study. And so if they're able to stay in their communities, they will be able to maintain their culture, maintain our identity, and keep being the guardians of our biodiversity.
Fantastic, thank you. Is it Mohammed?
Yes. Hello. Hello, my name is Mohammed Omar. I'm a GIS technical assistant. I work with RCMRD. So my problem, thank you, the panelists, for the wonderful presentations. So I have a question, and it might be a comment. It's on data access. So simply finding and downloading data is a challenge for most people who are outside this field. If someone searches on the web for a specific EO data, it doesn't lead to the data itself. So it leads sometimes to a data product page, which itself has the versioning or the attribution rather than the access. So by the time and someone finds that data, it has taken him a lot of time and effort. So, and there is also more than half of half a century of research in human computer interaction and user experience design that says graphical user interface are usually better for most people. So I think the earth science community or the geo or all of us should be recruiting user experience designers and incorporating usability into the core of our data center design and our data portals. Thank you.
So I don't know, Kofi, so that was the last question because we're running out of time. But Kofi, I don't know if you have something on data access that you want to say to kind of close us off.
Okay, so I wanted to make a quick comment and contribution. I see that a lot of time and investment goes into these platforms that we're talking about, the Copernicus ecosystem, the Digitide Africa, the Ghana Geospatial platform that we are creating. But I see that sometimes we don't put as much effort regarding the uptake. But what we want to see is that the Copernicus data ecosystem, the Digitide Africa platform is changing lives at the community level. And that means that we must put in much effort in the uptake as well, because we created these platforms to make impact. So when we create them and they are not being used and they are not making that impact, we will not be serving our purpose and humanity. So we should take critical efforts strategically to make sure there's really an uptake of these platforms, that we will see that lives are being changed at the community level. It's also, again, important that we ensure that we strengthen the national geos, because some of us gathered here are going back to our country. We have to ensure that the geo community in our respective countries are being pointed to these platforms and are making use of them and making relevant impact. So let's ensure that as a community, we strengthen our national geos so that we can have the needed impact that we are expecting. Thank you.
Thank you, Kofi. Very powerful ending message. So before we applaud our panelists, please remember to do the survey. I don't see anybody taking out their phones. Please remember to do the survey. And please join me in thanking our panelists for lots of food for thought for the geo infrastructure in this space-based data session. Thank you very much.
Thank you, Stephen. And thank you to the fantastic speakers. The key message we're hearing here is that geo and the geo infrastructure should be the glue to allow everyone to access this wealth of existing data and platforms. So we heard this morning that Earth observation is not just satellite from Barbara Ryan, but Earth observation goes into in situ data, and in situ data are essential ingredients in the cookbook for